Hi, this is Maragalam, Department of Information Technology here. Linear algebra in machine learning. Now let's see what is this linear algebra. Linear algebra is a subfield of mathematics concerned with vectors, matrices and transformations. It is a key foundation to the field of machine learning. So today's session we are going to discuss about the use of linear algebra in machine learning. So in this regard, we'll be discussing about few concrete examples like dataset and data files, images and photographs. Fine, let's start the session with data sets and data files. In machine learning, you fit a model on a data set. This is the table-like set of numbers where each row represents an observation and each column represents the feature of an observation. Example, let's consider this table-like structure. This is the data set representing the features of iris flowers data set. So this data is in fact a matrix that is a key data structure in linear algebra. Now, let us consider a supervised machine learning model. If you take any supervised machine learning model, the given data is split into two different components. One is the features and the other one is your class label. The features corresponds to the matrices and the class label corresponds to the vector. So, these matrices and the vector comprises the important components of a linear algebra which plays a vital role in machine learning as well. So next we are going to discuss how to load machine learning data in Python. You should load the data before you start your machine learning project. The most common format for machine learning data is CSV file, which is nothing but comma separated values. There are a number of ways to load a CSV file in Python. Let's discuss this. So we can load the CSV file using the Python standard library. We can also use pandas and we can also depend on this NumPy arrays for loading the CSV file into the Python environment. Let us discuss how to load a CSV file with Python's standard library. The Python API provides the module CSV and the function reader function that can be used to load the CSV files. Once loaded, you convert the CSV data to NumPy array and you can use it in machine learning. Fine. Let us discuss about how to load a CSV file using standard Python library. Fine. For that, the file have to be opened in RT mode. RT is nothing but read text mode. Then the reader function is called, which reads the contents of it. Then the list function is used for converting the observations into the list format. And this reader object is passed as a parameter to the NumPy array. Therefore, the example here, it loads the reader object that can iterate over each row of the data and can easily be converted into NumPy array. So running this example, you get the shape of the array, which is nothing but 768 by 9, 768 rows and 9 columns. Fine, this shows the content of the NumPy array. As we have stated in the NumPy array, the output form should have a floating point type. So accordingly, all the data, you could see that a dot is being added next to the integer part. We are going to discuss about how to load a CSV file with the help of NumPy's load text function. The NumPy's load text function helps us to read numerical data file in text format. The delimiter comma is specified here. So let's see the result of this code in the next slide. Fine. You could see the output of the NumPy's load text function. It is used to load the data from the text file. and we need to specify the delimiter as comma. The default return type is float. Next is loading a CSV file using pandas. It is a high-level data manipulation tool built on the NumPy package, and its key data structure is called a data frame. It helps to store and manipulate tabular data in terms of number of observations. We call it as rows and columns of variables. So you can load your CSV file using pandas with the help of read_CSV function. And in fact, you can even add the explicit headings as it is mentioned here, the code. You give a variable, you store the feature's name, and it could be a part of your output file. Let's discuss about how to load images in Python. So, when you're talking about the images and photographs, perhaps you're more used to working with images as far as computer vision applications are concerned. Now, each image itself is a table structure with width and height and 1 pixel value in each cell for black and white images and 3 pixel values in each cell for color image. A photo is yet another example of a matrix from linear algebra. Operations of the image such as cropping, scaling, shearing can be described using the notations and operations of linear algebra. So in the forthcoming slides, we are going to discuss about how to load and manipulate images in Python. So let us discuss how to load images in Python. So loading images in Python is possible only with the help of Python's image library called PIL. The extended or updated version of PIL is Pillow. So before we can develop any predictive models for image data, you must first learn how to load and manipulate images and photographs. So all this is possible only with the help of our Python's image library Pillow. So let's see how to load the image file here. So first you have to install Python's Pillow library and confirm that it is properly working. And second thing is that you have to load the images from the file, convert the loaded image to a NumPy array and store the images in new format. And finally, you can perform the basic transformations to the image data such as resizing, flipping, rotations and cropping. Now this simple code represents just the loading the JPEG file and reading the characteristic of it. So when you execute this file, you could see the resultant as JPEG file with RGB mode, and the size of this particular JPEG file is 680 x 680, which represents the pixels in the x-axis and the y-axis. So a few add-ons to the code. The images are typically in PNG or JPEG format can be loaded directly using this open function on image class. So in this code, we have used this open function on the image class. So this returns an image object which contains the pixel data for the image as well as the details about the image. The image class contains a tons of properties about the images as well as functions that allow you to manipulate the pixels and format of the image. The format property of the image will report the image format. Example, when you give image.format will tell you whether it is a JPEG file or something else. And the image.mode will display you the pixels channel format, that is it is RGB or CMYK. And the next is the size. It represents the dimensions of the image. And the next is the image.show. Using this function, you can display the image which just got loaded to the Python's environment. That's it. Now, let us discuss how to load the images in Python using matplotlib. So often in machine learning, we want to work with images as NumPy arrays of pixel data. With Pillow installed, you can also use MATLAB library to load the image and display it within a MATLAB lib frame. This can be achieved using imread function, which loads the image as an array of pixels directly, and imshow function that will display an array of pixels as an image. So the code explains how to load and display the image using matplotlib. So running the code first loads the image and then reports the data type of the array, in this case 8-bit unsigned integers. Then reports the shape of the array. In this case, it is 680 cross 680 and the number 3 is given, meaning 3 channels, RGB. And finally, it shows the loaded image. So this is the continuation output of the previous code. We just asked to plot it, the image which just got loaded. So we could see the image is plotted in the matplotlib frame. Fine. Let us discuss how to convert an image into NumPy and NumPy into image. So let us discuss how to convert the image into NumPy array and vice versa. To access the pixel data from a pillow image, the simplest way is to construct a NumPy array and pass in the image object. The process can be reversed, converting a given array of pixel data into the pillow image object using image.fromArray function. This can be useful if image data is manipulated as a NumPy array, and then we can save it later as PNG or JPEG file. The example loads the photo as pillow image object and converts it to a NumPy array, followed by converting it back to the image object. The result of the code is given over here, that is the array output followed by the characteristics of the image with the size of the image. So let's discuss the last topic of the session, converting an image to a grayscale. There are a number of ways to convert an image to a grayscale. Pillow provides convert function with the mode capital L to convert an image to a grayscale. Now let us have a glance at this code. We have to use this image.open function to load the image to the Python environment. Then this file object is passed as a parameter to the convert function with the mode capital L. So this converts the image into the grayscale pattern, and in order to save this converted image, we use this save function with a different file name. And finally, we can just load it and show to the end user. Okay, so let's see the output of this. So this is the grayscale pattern of the image which just got loaded into the Python environment. So before I conclude the session, I would like to insist a few points. Point number 1, linear algebra serves as a basics for all ML algorithms. Second thing is that the key data structure of linear algebra are vectors, matrices, and the transformations. So through the discussions, we have understood that how these vectors and matrices plays a vital role in performing this dataset operations and the image manipulation operations. So as of now, we have discussed how to load a data set into the Python environment and how the Python is going to treat the data set, that is in terms of matrices. And also we have discussed how to load an image or photograph into the Python environment and how it is being treated internally in terms of the vectors or matrices. Okay, Therefore, the conclusion here is that the linear algebra serves as a basic element for all the machine learning algorithms.